Okay, here's warm-up number 20. I think it's going to be a fairly quick one. 1 and 6, I'm identifying angle pairs. This might look a little familiar if you've done the other warm-ups. But okay, 1 and 6 are on opposite sides of the same intersection. Those are called vertical angles. All right. 4 and 5, these are on outside of the tracks. They're on different sides of this transversal. So those are going to be alternate exterior angles. I'm going to abbreviate here. Alternate exterior angles. Okay. 6 and 7 are inside the tracks. They're on the same side of the transversal. I like to say same side interior angles. Our book calls them consecutive interior angles. Consecutive interior angles. Okay. 2 and 7, these are inside the tracks, different sides of the transversal, different sides of the red line. So those are going to be alternate interior angles. Okay, and then 2 and 7 inside the tracks again. Sorry, already 2 and 7. 5 and 7, sorry. 5 is on the bottom left of its intersection. 7 is on the bottom left of its intersection. So this one's exterior, that one's interior. So you can't use interior or exterior. These are corresponding angles. They're in corresponding positions. Okay? All right. So on to the next column here. Number 6, solve for x. Identify the theorem you used. I've got two parallel lines here, which means I can use the angle pair theorems. Okay? Now these two angles are in corresponding positions. They're in the top right of their respective intersections. So we're going to use the corresponding angles theorem. That's the theorem we're using. So that tells us that those two angles are congruent. And now, if those angles are congruent, their measures are the same. So I can say 6 minus 11 is going to equal 37, and I can solve for x now. Okay, so I'm going to add 11 to both sides. And then 6x is going to equal 48. Divide by 6. And x will come out to 8. Okay, and then last two problems. What theorem proves that the tracks are parallel? Well, in this case, these are corresponding angles. Here they're already marked congruent. So remember, this was when we had that the tracks were parallel, and we said the angles then are congruent. That was the original theorem when we started with the parallel lines. When you start with something about the angles and then say from there that the lines are parallel, that's going to be the converse of something. Here it's the converse of the corresponding angles theorem. Okay, and then likewise I know something about these angles, so this is going to be the converse. I just have to figure out the converse of what. So these are on the outside of the tracks and they're on different sides of the transversal. This is going to be the converse of alternate exterior angles theorem. Okay. If you forget to write the word converse, you can always put it at the end. You could call this the alternate exterior angles theorem converse. Forgot the word of here, but that's okay. All right. And that's it for this time. See you next time.